Pythagorean identities. Okay, you have to know identities to do this. There's two ways to do this.
Go crazy.
Okay, actually there's three ways. Holy crap. Okay, so I have cotangent theta times, what is the reciprocal identity of tangent?
Cotangent.
It's 1 over cotangent. Okay, now think about this. Now, if I were to multiply this number to this number, you'd make this over 1, right? Oh, dang it. Why does it say cost? Oops.
Costco.
Okay, it's just caught. Okay, so if I multiply this guy to this guy, what would I get?
1.
1, because you get cotangent theta over cotangent theta, right? So that equals 1. Yay. Check. Okay. What's another way to do it?
The other way. Tangent equals 1 over cot.
Yeah, okay, so we could, wait, isn't that what I just did?
Then cot equals 1 over.
Okay, so I could say cotangent is 1 over tangent times tangent, and I get the same result, right?
Yeah.
Okay, what about this? What is the quotient identity for cotangent?
Cosine over sine.
Cosine over sine. And what is the quotient identity for tangent?
Sine over cosine.
Now, if I multiply it straight across, don't I get the same thing on the top and the bottom?
Yeah. 1.
So this also equals 1. Proven. Okay, now the more fun one is this guy.
Whoa, no. Okay, so more work.
Okay, the next one requires use of the Pythagorean identity, which we haven't talked much about. So let me show that to you guys really quick. Now for this next one, you're going to need to know the Pythagorean identities. Now the Pythagorean identities come from, like if you're looking inside the unit circle, all of our coordinates right here make a right triangle. Now if you think about that, think about it slowly, the x is cosine, right? And the sine is the y value. In our unit circle, the hypotenuse is 1. So this means that our triangle in here, this is cosine theta, this is 1, and this is sine theta. Now if you know that, then you know that sine squared theta plus cosine squared theta equals 1 squared. That's the Pythagorean identity. A squared plus b squared equals c squared. Now of course you don't need the squared on the 1, but this identity is what you can use to do a problem like this. Now the fun part, well I think it's fun, you might think it's annoying. The fun part about the Pythagorean identity is that he has all these other identities. Sine squared theta equals 1 minus cosine squared theta. And all I had to do was take away cosine squared theta from both sides. And then I also know that cosine squared theta equals 1 minus sine squared theta. All right, now if I'm looking at this and what I know, I'm seeing that there's a cosine squared over here, but there's none over here. And so my first move would be to get rid of this cosine squared theta. Now if I was using a Pythagorean identity, what does cosine squared theta equal? So I'm going to take out this cosine squared theta and put in this stuff right here. I'll put it in a different color so it'll pop for you guys. So I have sine squared theta. And in there I'm going to put this guy. So we have 1 minus sine squared theta. That is the same as this guy, cosine squared theta. And so then I just take that and I distribute it. I get sine squared theta minus sine to the 4th theta. And I get a 4 because I'm supposed to add exponents when I multiply similar bases. Okay, the signs are the similar bases. And so we got what we wanted to. So we got there. Check. We're done.